To realize is that I've been teaching using text studio. So I type my integrals and then it just shows up so you can be able to see that um, I use this what's it called? I use Inkscape the last time because I needed to basically write, and I was using this tool to be able to draw certain integral signs and stuff like that, just as if I was writing, which it's quite helpful for me in this sense. I realized that using this, I'm able to at least draw my integral sign. So if I'm teaching and then I write this or I do this, what I am believing is that my students will be able to see this as an integral sign, and then I can also type the function. So I can basically write whatever I'm working on right here. Because I do not have a board, there's what's it called? There's a tool that I can use in my class. I think that is is it Jam or something? Yeah, Jam board. Again, I'm trying to figure out what is the best thing to do. I can delete this. This is here. So again, I can use this, and then maybe I said I'm integrating from A to B, and then I have f of a function f of x, comma y, what's it called? I'm basically trying to close my bracket, yes. The x, so because I'm dealing with double integral, I'll need another integral from c to d. This is dx, and this is dy. So my biggest challenge in teaching this is for whatever I'll have to do for you to see what is on my screen. But the challenge is if you're using your phone, then I'm not sure how you are going to be writing notes while I do it. But if you have an environment that is conducive for learning, where you have a laptop, or you can even if it's not that you have a laptop, but you have your phone, you can put the phone down and you also have a notebook. It might help because you can, as I'm projecting this, or this is on your screen, you can actually write down that this is what Aram is writing, right? So I'm also thinking about tools, the various tools that I can use to make my presentation easier for you and to be able to help you grasp what I'm doing. So if you haven't thought about creating a learning environment or a conducive teaching and learning environment for yourself, please, that is something I want to throw out today. It is important for you to have what? A conducive learning environment. It's very, very important for you to have a conducive learning environment. Because you may have to write down notes, even though I've uploaded the textbook and I'll be uploading my slides while I'm explaining, you may have to write down a few things. Now that I'm showing my entire screen, so if you're chatting, I may not see the chat because I'm completely even off the what's it called here. Okay, so there are a few chats and I'm just here to read. Thank you, sir. Please, Mr. Joseph Mante taught yesterday greatly. He was writing on the screen perfectly. Please, sir, you can ask him for help. Thank you. I think I appreciate that. He was basically writing on the screen perfectly, and I can ask him for help. That's not a big deal. My biggest challenge is not asking him for whatever he uses, but if I have access to the same tools, and if what he was teaching was the same as what I am teaching. So my biggest challenge is not what tools I can use. I think there is a, what's it called, Jamboard, as I rightly pulled out for you to see. So this is a Jamboard, and the fact that I have a Jamboard means that I can write on it as I have just done. However, my biggest challenge is this: if I write this and you didn't write it down, because I'm talking about you having notebook and other things. If you don't write it down, then it means that once I clear up the screen and I move on to the next screen, then you don't have it recorded down. But I have slides which I can show. I have slides. I spend a lot of my time preparing my slides so I can upload my slides for you. Okay, so let's have this conversation around him writing on the screen. If he has a possibly, maybe he has what's the call, a touchscreen laptop that you can, that takes an input device, you can write on it. And I don't have a touchscreen laptop. I am definitely not going to buy one because I want to be able to write on it. Am I making sense? You can unmute and we have this conversation. Please, let's have this conversation.
Yes, sir.
Yes, what you're saying is right.
So with the Jamboard, this is the Jamboard. You can actually write on it if you have an input device such as pen, and it means that you need a touch screen to write on.
Yes, sir.
But if I don't have a touch screen to write on, then, and I don't have an input device to write on, because there's also, I know there's an input device. I think I've seen a colleague have the input device, but there's a particular lag. So if you draw a line, it doesn't actually show up. So I do this, and it takes a little while for it to show up. But with the Jam, the challenge is you can easily, it's just like Corel Draw. I don't know how many of you know about drawing softwares. You can basically do that, but you would need to have what? Check my entire screen. You will need an input device to be able to get that done.
I think this one is okay. We'll manage with this one.
Thank you. No, but my emphasis here is that you must have a notebook. So while I'm writing, you can write.
Yes, sir.
Because I realized last time, the last time when I did my class, I was using what's it called? I was using Text Studio. So I was typing and then the output shows up.
Yes,
Okay.
you have to.
Exactly.
And they're going to write
Last
it.
week, when you were using the text studio, me myself, I was confused. But today, if you are going to use the board and we are supposed to write, then I think we'll get it right.
Okay, so that is a very important feedback. You said when I was using Text Studio, you were confused.
Yes. So I think.
What was the problem? Because it didn't, because if I, okay, so a typical example is if I'm using Text Studio and I'm typing here and I'm typing in this window is not for you. This window is for you. This is the output window. This is where you, so you wait for me to finish typing and then I run it so you can see what I'm putting out.
Okay, sir.
Yes.
Yes, sir.
This window is basically for me to type. This window is for me to type. But this output window, this other window here is for you. So this window is not for you. The highlighted window is not for you.
Okay, sir.
This window is for you. This one, where you see the blue example 2, that window is for you.
Okay, sir.
Because this is the gives me the opportunity to be able, I type as a script, write my script, and then I run it to generate this output. Because if I think that if I put this here, example is go back and look at what's the call, um, equations and 7. Fubini's theorem. Did I go Fubini's or I just included it? I just included it basically. So if you look at this 6 and 7, saying that if I integrate with respect phase, if I respect to phase, integrate with before I integrate with respect to x, I'll get the same result as if I with respect to x first before I integrate with y. That's what the theorem is saying. Now, if I am teaching this, so I can go to Jamboard and then write this. That's what I've just done. That this is the same as what? This is equal to what? A to B. So this is my biggest challenge writing. Come again.
The jump
See
board.
the word. They're not seeing your word.
You can't see what?
The presentation.
The presentation
You
is
can't
in a
see
small
my
tab.
presentation. I think it was.
Your screen.
Resume. Thank you. Thank you. So so a typical example is where I've been trying, if I use the text studio and I type this, the blue screen, the highlighted one, this side is not for you. This is for me to type, but this is the output of whatever I'm typing. So it means that this side is for you. Where I'm highlighting now with the, what's it called, the magnifying glass. This is for you to see. So when I type, I am typing my script here, and then I generate equation 6 and equation 7. That basically they're the same. So I am not you to find out, okay, how am I generating this? If you know how to use Text Studio, which I think that BME, some of the BME students know, then they may be able to understand what is going on here. But for you, the rest of the class, I am just trying to generate this output for you. So if this is confusing, then I have to figure out what else to use. And I think that the Jamboard might be the best way to go about it. But the challenge using my, what's it called, my mouse to generate whatever I want to generate. I am basically trying to use my mouse to do that. So that is my challenge with using this to be able to explain. However, I would always upload, when I finish my class, I'll upload the slide for you to have. Does that make any sense? When I finish teaching the class, I will upload the slides for you. So if you're not able to make notes during my lectures, you are definitely assured that I'll upload the slide for you to get. Okay, so let's go over what we did the last time. Basically, I've introduced double integral. And I said one of the ways in which we do double integral is I actually introduced it from a geometry point of view. And I said, if you have this rectangle, if you have a rectangle which on the x-axis starts from A to B, on the y-axis is from C to D, that is the length. The length is D minus C, and then the length is B minus A, and the breadth is what? D minus C. Then we know that the area of this region, so R is for the region, that is the shaded region. The area is given as what? Length times breadth, which is what? B minus A times D minus C. Now, if we concentrate on this formula, the question is, can we find a way to obtain this result in calculus? Yes, we can do that. We can do that by this. So it means that B minus A can be obtained by what? Integrating 1, because when you integrate 1, you have x. integrate 1 from what? A to B with respect to x. And once I do that, I'll then evaluate what? X, B minus A. I'll be able to get that. So from calculus, I can obtain this formula, this area formula. The area for this rectangle, or the rectangular that I have here, I can obtain that from calculus. So then this gives me a fair idea. If I have this integral, then I can of course pull out the integrals and have something that looks like this. Therefore, the area of that rectangle can be obtained as this. The integral from A to B, and then the integral from C to D, dy dx. Then I use this what? The inner integral first. So I can actually have this integral without the, what's it called? Without the bracket. But if you are going to evaluate it, you must do the inner integral first. So if you look at this, the volume integral, similarly, we obtain volume from calculus as this. And I explained that what the volume does is that we now have a height. So this is giving you area just as this, but now we are getting a height which is modeled by the function. The function is what the height is. But again, the order of the integration is that you integrate what? Y first before you get to x. So this, you do the inner integral, and whatever results you get will now be done with outer integral. Is there any question somebody wants at this point? Any question?
No, sir.
Teresa, I don't understand what you mean by it made you skip some steps.
Please, I'm talking about the test studio. That's the app.
Oh, the text studio. No, I didn't actually skip the steps. I typed all the steps out. A typical example is this. This is a complete work. Please hold on.
Okay.
Hello, Captain. I'm good. Okay, all right, guys. Uh, So I'm still addressing the issue of me jumping steps. You said it made you skip steps when I use the text studio. So one of the things you have to do for me is this. Please let me know if you feel that I'm jumping steps. I think that would be the best way, because a typical example is when I'm doing an integral, which I think I will do. Some of you said I should solve this, I should go over the example. I'll go over the example. If I'm solving an integral and maybe I'm supposed to get s squared over 2 or something as a result, I may just write down the answer and then said, okay, when you integrate, this is what we do, because this class is built on Math 2, where you have learned all techniques of integration. So yes, I may jump steps because I feel that in integrations. But if you feel that I have done something or I've skipped a step which doesn't help you understand what I'm doing, please feel free and let me know. Thank you.
Okay, sir.
Okay, so I basically introduced double integrals as something you can use to find area and then volume. So there are two things I spoke about. The area, you just do the double integral, there's no function. For area, there's no function. But for volume, there is a function, because this function then models the height of the object. So the area, you just need length times breadth, you don't need height. But for volume, you need length, breadth, and height. So you need a function to be able to account for the height of the object for you. Good. Then I plotted sine of y. I plotted this. And if you look at it, x starts from 1 all the way to 3. And then y is from 0 to what? To 3 pi over 2. So I have the area right here, which is still like a rectangle, and then the height. So at this point, you rise up to this, but in the middle somewhere here, you rise all the way to 1. So this clearly tells me that breadth and then my height. So if I integrate this, I am possibly looking for a volume. So how do we do this? We do this by integrating from along the x-axis, you start from 1 to 3, along the y-axis from 0 to 3 pi over 2. So I have the y that I'm integrating with respect to y from 0 to 3 pi over 2. But for the x, I'm integrating from 1 to 3. Then I have the function f of x times y, which is x times sine y, and I integrate. My first integral is with respect to x. And if you integrate, this has absolutely nothing to do with x. So I'll keep this as a constant. Then I integrate x, I have x squared over 2. Now I'll have to evaluate from 1 to 3. So I've written it right here. Integrating from 1 to 3, x squared over 2. While I am waiting for the other integral for y. And then now I integrate y. When I integrate y, sine y, I have what? Cosine, negative cosine of y. But what is negative cosine of y evaluated as 0 and 3 pi over 2? The actual result is what? Positive 1. Because cosine of 3 pi over 2 is 0. Then minus negative 1, and that gives me positive 1. So 1 times 4, I have this. But what if somebody had decided to integrate, a case where you integrate with x first before y? Now, if I reverse the order, I want to integrate with y before x. And please watch, I didn't just switch the order. I didn't just change the x and the y. I also did what? Change the limit of the integration. So if you look at this, The x goes with what? The limit 1 to 3, and the y goes with what? The limit 0 to 3 pi over 2. Now, when I change the position, dy still goes with the limit 0 to 3 pi over 2, and ds goes with 1 to this. But now what it means is I'll have to integrate first with y. So when I integrate first with y, I have this. But this I know is just positive 1. Then I can also integrate from this, which then gives me my 4. So whether you integrate with y before x or you integrate with x before y, the same way. And let's call the Fubini's theorem. This led to what I call the Fubini's theorem. So in doing double integral, there's a theorem that says that if f is continuous on the rectangular region for all for the pair the point x comma y, where x is between a and b and y is between c and d, the double integral of f over the region R may be evaluated by either of two iterated integrals. So you can either use this. So if you look at the order, you can either integrate with y before x or with x before y, and that has clearly been demonstrated here. You get the same result. So when you are integrating the same function, you can do y dx, dy dx, or you can do dx dy. You get the same result. It doesn't make any difference what it is. Which order you use, you get the same results. However, it is important for you to know that sometimes, depending on the nature of the function, it may be easier for you to integrate with y first or with x first. So the other examples I've given attempt to do that. Actually tells you that it will be easier to integrate with one variable than the other, but you know very well that the result is the same. Whether you integrate with this or that, you get the same result. Good. Now I have given this example where I said find this over the region. So I'm going to try to explain this. So we want to find the volume of the solid bounded, and I ask you to use both possible orders of integration. So you can integrate with this before this or that. Let's do example 1. And I'm going to use the jump box to do this. Z is equal to what? What's the function? I think 4 plus 9s squared times ys squared. Good. So this is what I've been given. So I've been given 4 plus what? 9 s squared y squared. I am supposed to find, please let's go over the question again. The question says what? Find the volume of the solid bounded by the surface over the region this. And I've been told that x is between -1 to 1, y is between 0 and 2. So I have a situation where x is bounded between what? Less or equal to -1. Please, I am not checking the chat session. So if you have a question, please ask, unmute yourself and ask, because I'm not checking the chat session. And then y is between 2 and 0. Good. Now I am looking for this. I can call this out. The first thing I'll do is what? I'll let z to be equal to what? F of x comma y. Z to be equal to f of x comma y. and that is the 4 plus 9x squared y squared. So if z is equal to f of x, then it means that my volume then the volume is equal to what? The double integral. I'll integrate from 0 all the way to 2, and then I'll integrate from where? -1. So this is -1 all the way to 1, and I just put the function down. 4 plus what? 9x squared y squared. Nine x squared y squared. But the way I have arranged my order of integration, it means that I have to do which integral first?
The x.
Thank you. I have to do that. Thank you. I have to do the dx first. So I have to do x first before I do y. Is this okay? Is everybody okay with this arrangement?
Yes.
Yes, sir.
Thank you. Thank you.
Yes, sir. I'm okay.
Yes, sir.
Okay. So now that we have arranged, we know that the volume we are trying to obtain is given as what? The integral from 0 to 2. Then the other one is -1 to 1. Yeah, 1. 4 plus 9 s squared the x, sorry, yeah, I'm writing with my mouse, so you can imagine. And dy. If you integrate this, what do you have? This clearly tells me that I'll keep my integral 0 to 2 because I'm not touching the y yet. But now when I integrate this with x, I have what? 4x plus, if I integrate this with x, what do I have? It becomes what? 3s cubed, right?
That's 3x cube y squared.
Thank you. So this is where, what's it called? Is it, Teresa, you might say I've jumped a step. What's the name? Yeah. Which one is the first name? Teresa, right? Or
Yes, sir.
Amana? I'm not sure. Is Amana your last name or your first name or middle name? So in this case, yes, I have jumped a step because I just wrote this. I said I've integrated this. And so if you don't know how I got the 3s cubed, please ask now. I believe everybody knows how I got the 3s cubed.
Yes, sir.
Thank you. Good. So now I have to evaluate this. That is, replace all the x values with the 1 and the -1. So this gives me my integral from 0 to 2. And then I have what? 4 plus 3y squared minus open bracket -4 minus 3y squared. Am I right?
Yes, sir.
dy. Yes, so this is what I have. But this, if I multiply through with the negative, they become plus. So it means that actually this becomes what? The volume becomes
Yes, sir.
2 times what? The integral from 0 to 2, 4 plus 3y squared. Are we okay with this? Because if I multiply through with negative, this is the same thing times this. So I have this plus this, they all become plus. So 4 plus 4, like 8. Then this gives me 6. I can factor the 2 out. So I have this as a result.
Okay.
Now I have to integrate this with respect to y, which I will do. So this is equal to, I keep my 2 here, and then I do my integration. I have what? 4y plus what? Y cubed, right?
Yes.
Then I'll evaluate from 0 to 2. And this then gives me what? 2 into brackets 8 plus 8. 8 plus what? 2 raised to the power 3. So let me do this. 2. Let me do this. 4 times 2 plus 2 raised to the power 3. You guys are blessed to have the cock crowing at the background. I think the result becomes 32. Am I right?
Yes, sir.
Yes, sir.
It's an example. I think it's an example I took from the textbook, so you can compare the answer in the textbook. It's one of the examples I took from the textbook. I don't remember exactly which of them, but I'm trying to figure out. Uh, so I have actually
Yes, sir. That's true.
32 from the book. Somebody can confirm that. I don't know. It's an example I picked from the book, so you can just check.
So that's the right answer.
Yeah, it's 32. It's right here, 32. So it's something I've taken. So I wrote the example from the book. I haven't actually solved it. So I just put it down for you to look at. Good. Okay, so with a Jamboard, this is the best I can do, and I'm trying to write with what using my mouse to write this. But if you are not writing notes and I do this and take it off, the only other option you have is to go back to my slides. But in my slide, I may not type the answer because I feel I have discussed the answer in class. Okay. Then the other example, I think I have a few minutes to run away, but let me just discuss this because it's important to me and it will help introduce my idea. Let's look at the second problem. The second problem is this. It says evaluate this integral 6x to the power 5 e raised to the power y times s cubed dA, where r, that is the region over which I'm supposed to do the integral, is what? X is between 0 and 2, y is between 0 and 2. So that's actually y squared. I'm supposed to find this volume. Basically, if you look at this, I'm going back to this. It tells me that I am trying to find a volume. In this case, I have all of them from 0 to 2. 0 to 2. Then what's the function? Please, somebody, 6.
6x raised to the power 5.
X to the power 5. Yeah. Thank you. 6x to the power 5.
6x
And
power
then
5.
e exponential
E to the power y x cube.
s cube.
Y x cube.
Thank you. Okay, so this, and I have written the limit 0 to 2, 0 to 2 because they basically have the same limits. But now the question is this: should I integrate with x first or with y first? Should I do the x, which one? The x, dy, or dy dx? What do you think? Which one will be easier to do?
The X, the Y, sir.
We should do x before y.
Yes, sir.
Why? Why do you want to do x before y?
Any order would be right, but for me, I would prefer I would start with X first. Since both of them have the same bound.
They have the same bound, so you can start with x first. That's what you think. Anybody else has a different view?
So I suppose you start with y.
Why?
The y there. Because of it is kind of complex. So we have to solve it to be able to approach the x.
Sir, because I think we have to use substitution here.
Sir,
We should use what?
Because of
I think we can start with any of them.
Hello?
Sir, I think we can start with any of them.
Okay, all
Yeah,
right. So
let's
I
Sir, I
have
think we can
start
start
with
with any
y.
of them.
Sir,
The y
y.
first.
If you say x, give me y. If you say y, give me y. You need to tell me why.
sir, it
So let's
depends
start with
when
y.
Let's start y so that
Then
the u will cancel out.
x first.
Okay, so let me tell you one of the things.
Any of
Please,
them that
please, please, let me just tell you something. Those of you who said we should start with the x.
So let's start with Y.
Okay, so those of you who said we should start with x. If you start with x, what is going to happen? So let's do this. If you do this, what happens? If you want to integrate this with x, what method will you use?
substitution.
use substitution, sir.
Substitution will not work.
Use substitution.
Use substitution will not work. You have to use integrations by parts. You don't have a choice. Because this is a polynomial times exponential function. So those of you who say we should start with x, no, this becomes more difficult for you to do. But if we start with y, that is this. What it means is the first integral will be done with y. Now you can use your u substitution to do it. And so I'm going to tell you, if you integrate with y, this is what you have. Integrate from 0 to 2, you keep this integral. Then we're integrating with y.
$300. We right now is $800, and that you can get to me.
Is somebody talking to me? Please, is somebody talking to me?
And
Is somebody talking to me? Should I listen to somebody else?
No, sir.
Okay,
No, sir.
No, sir.
thank you. So I'm integrating with respect to y. How? Because I'm integrating with respect to y, I have absolutely nothing to do with what? 6x to the power 5. So I'll keep that. Then I'm integrating this. But if I integrate this with respect to y, what do I have? I have e raised to the power y times x cubed raised to the power 3 times s cubed, and then all over what? S cubed. Does this make sense? I'll evaluate from 0 to 2. Is this integral right?
Yes, sir.
That's also
Is this integral right?
Yes, sir.
Please, if you don't want to talk to the class, please mute your microphone. But if you are talking to the class, please. Are there some? No, there's no. Actually, nobody's chatting with me, so I'm okay to stay here. Good. Okay, so the class has actually gone to say something. Good. So I have this. Now I have to evaluate this. And if I evaluate this, what happens? I'll have what? Now this S cube can cancel this up, right? S cube can cancel this up. So this gives me my volume. My volume becomes something like this. 0 to 2. Then I have what? 6x squared. 6x squared. And then the other result, what am I getting?
Say S to the fifth power.
E raised to the power what?
E raised to the power 1.
S cubed.
Why?
Minus 1.
Oh, yeah, I'm waiting.
Does this make sense?
Doesn't.
It doesn't.
No, sir.
I am evaluating
Sir,
this.
can you
These
go
are the
again,
values of
please?
y, right? These are the values of y. So e raised to the power 2. So you replace y with 2, and then you replace y with 0. E raised to the power 0 is what? What is e raised to the power 0?
1.
Thank you.
1.
Okay, so please, one of the things you need to know about this class is that I am building on math 2. If you have forgotten math 2, please review it. If you have forgotten math 2, please review that course. All right, so this then gives me this as a result. So I now have this to integrate. I'm integrating 0 to 2. 6 what? Oh, this is cube, please. 6s. This is cube, yeah. 6s squared e raised to the power 2s cubed.
Sir.
Speak.
Sir,
Minus 6s squared.
The beginning of the problem we have 6x to the fifth power.
Thank you. Yeah, I'm listening.
Yeah, but now we come down, we having 6x squared. So
And what is the problem?
Sir. You change the
What is the problem with that? Have you seen this? Have you seen this section? Please, have you seen this? I'm right here. I'm
Yes, sir.
projecting something to you. Am I still projecting?
Yeah, I'm
sir.
seeing that.
So you have seen this, right?
Yes, sir.
How did I get this? How did I get this? How did I get this? What I am circling.
Okay.
How did I get it?
No, I get you. The S cancel SQ from the 6S.
Can I move
I get
on?
you, sir.
If you get it, can I move on?
Yes.
Yes, I'm moving.
Yes, sir. Yes, sir. Yes, sir.
Good. Okay, so now we can integrate this. And right from here, this tells us that this result becomes what? Now you can integrate this using the substitution method you want to use without using any integrations by parts. So you use a U sub. You let U equal to all this at the top. When you differentiate, you have what? 4s squared. The s squared will cancel out. So you then have what? 3 over 2. 3 over 2 e raised to the power what? 2s cubed. So this is 2, please. 2s cubed minus, when you integrate this, what happens? This becomes cubed. So 2s cubed. Then you evaluate this from what? 0 to 2. Does that make sense?
Yes,
And
sir.
the work is done. Are we okay with this integral? This part of the integral. This is okay. You use a u sub.
Yes,
So
sir.
u is equal to what? 2s squared. And when you differentiate, du becomes what? 4x squared. So it means that the s squared will cancel out. Then you have 6 over 4. 6 over 4, I can write it as 3 over 2. And then I have this as the integral. If I integrate this, I get this. Because right now, if I differentiate this, I'll get this back. If I differentiate this, I'll get this back. Is that true?
Yes, sir.
Yes, sir.
Please, if you differentiate what is here, will you get this?
Yes, sir.
Please hold on, there's something not right. If you differentiate this, you get 6x. So you should cancel all the 6. This should not be there, please. This should be cancelled. Because when you differentiate this, you get 6x squared. It's not 4x squared, it's 6x squared.
Yeah, 6
If you do the u stuff, you get 6x squared. So it takes care of everything. So there's no fraction. You don't have anything right. This should be cancelled, please. And then you can then evaluate this now. So this gives us a final result of what? E raised to power 2 cubed 16. You have 16 minus what? 16 minus.
Can you go over that again?
6.
Minus 1. I think I should get 15. Yes, please speak. Someone is asking me to go over something again.
So x raised to power 3 should be minus 16.
Someone is asking me to go over something again.
Yes, the last part.
Yeah, that part.
Can you please go over
Go
that
over the
question
last part
again?
again. How you got the E?
Can I go over what?
Yes. Please go. The last part, please.
Your lines
How
are
you got
breaking.
the
I can
E
hardly hear you.
to The network is bad.
So I use U sub. So U substitution. Do you know how to do U substitution?
So
Do you
again,
know how to do U substitution?
Yes, sir.
So you do this. I'm going to write it right here. Okay, so let's go to the other slide.
so I guess we could also use exponential function as well.
You can use what?
Exponential.
Let U equal to what? 2s cubed. Then du dx. Du dx is equal to what? This is x squared. This was where I said it was 4x squared, but it's not 4x squared, it's 6x squared. So it means that what dx, I can write this implies that this whole thing implies that dx is equal to what? Du over 6x squared. So this integral, which is from 0 all the way to 2, 6x squared e raised to the power 2s cubed dx can be written as what? The integral, if you like, you can change the limit, but if you like, you can also keep the limit and then convert back. I'm not bothered at all. So this becomes what? I'll leave the limit for now. 6x squared e raised to power what? Instead of the 2s cubed, I'll put u because I have made a substitution. U is equal to that. Then in place of dx, I'll put what? Du over what? 6s squared. And this will cancel out. So I'm just integrating. So when I integrate, I have e raised to power u. And what is my u? U is 2x squared. That's exactly what we got. That's how come we got. That's why I said that this needs to be cancelled, because I said when you integrate this, you have 4x squared, but that is not true. This is 6x squared. So it cancels out completely. So you have this. Now, if you differentiate this, you should get this back. If you differentiate this, you get the 6s squared times this. And if you differentiate this, you get 6s squared. So this is indeed an antiderivative of this function. When you integrate this, you get this. When you differentiate this, you get this. And then what I did next was to apply the limits. 2 raised to the power 3 is 8 times 2, 16. So e raised to the power 16 minus this is again 16. But e raised to the power 0 is 1. So
it will be minus 17.
Thank you. I think I just figured that out. That it should be minus 17. So this should actually be minus 17. Thank you. Negative 16 minus 1 is negative 17. Thank you. Okay. Can you imagine? I can't even write back on the one. Okay.
So there's an eraser near at the bottom of the pen you are using.
That's even erasing in itself gives me, but at least it's better than that anyway. Thank you. Okay, thanks. So this gives me my 17. So I can again erase this. Okay. So you realize that even though we said, what's it called? Going back to this, even though we said the same integral can be done either with respect to x first before y or with respect to y first before x, we've just realized that depending on the problem, it might be easier to use a particular technique or to integrate in a particular order, right?
Yes, sir.
It may be easier. So in this problem, the problem we just solved, it is way easier to start with what y than to start with x. So if you like, you go back and try solving this with respect to x first and see how far it takes you. You would have to start with integrations by part along the way and then see, because you can use the use up and see what happens. It will only reduce the order of this for you, but you may have to do integrations by parts. Whereas by doing y first, it makes the problem a lot more easier. Good. I'll have to end the class here for today because I'm already late for my meeting.
Sir, what are we? Sir, please, what are we
Thank you
doing?
very much, sir.
Sir, please, what are we doing next week?
Yes, thank you.
So I'm continuing with this. I'll discuss what's it called over general regions. So if you look at what I have done so far, I have basically dealt with only what rectangular regions. That is, if x and y are just numbers, if x is bounded between 0 and 1 or 1 and 2, and then y is between 3 and 1. But what happens if it's bounded by functions? So I'll discuss again double integrals over general regions. That's what I'm going to discuss. And I said that is in section, I think section 14.2 of the book. So I'll be going to section 14.2, this area, yeah, section 14.2. So I'm going according to this book actually.
Okay, sir.
So after 14.2, I'll go to 14.3. So basically that's what I'm going to do. So double integral is 14.1 for the general, the rectangular region, 14.2 for general region, and then 14.3 for polar coordinates.
The presentation is not coming, sir.
Come again. Somebody else is talking to me.
It's saying the presentation is not coming.
No, you have the textbook. I've uploaded the textbook online. I'm telling you that I will be going to section 14.2 of the textbook. Because somebody asked me, what are we doing next week? Okay, so last week, that is this Monday,